Hello everyone, welcome to this presentation. Today my presentation topic is on basics of code smell. Let me first introduce myself. This is Prosanto Deb, a student of Bachelor of Science in Software Engineering, Institute of Information Technology, Noah Valley Science and Technology University. Thank you our honorable teacher MD Vishagadir sir for giving us the opportunity to present my presentation. So let us go through the table of contents. I will discuss about bloaters, object-oriented abusers, change preventers, dispensables, and couplers. Before going to the main part, let me discuss about what is code smell. A code smell is something in your code that will show the output as you want, but will make the code that you cannot maintain. That means if you change in one part, you have to change in other parts too. And ultimately, your code will not be maintainable, but you will get the output as you want. So we want to remove code smells from our code. So in bloaters we have various code smells. We have long method, primitive obsession, data clumps, large class, and large long parameter list. In our code, a method which is more than 10 lines will make questions that is your method is right or no, because a long method is not good for your code. We have to break down the long methods into small parts and use each of them. So at the very beginning, if we see a code example, we have a method called print meal status, and the main part is considered as the meal rate calculation. If we break the meal rate calculation into a new method, then we can get maintainability. If we make a new method called get meal rate, which will return the calculation, and we will then go our next step, which is check that if the meal rate is more than 13, which is not good, and else the meal rate is good. Our next part is primitive obsession. We can have various types of data types. If we want to make a good house, we have to make use the data types properly. For example, in the class order, we can create a variable called customer name, which is type of string. But if we have more and more properties of customer, then what will we do? So the better solution is we will create a class called customer, and in the customer class we will add the properties, and we will make a variable of customer at the order class, which will make the code more maintainable. Data clumps. In our code, we can have many various parts that are doing other responsibilities, like one is playing, and one is swimming, and one is taking rest. But if we want to make our code more standard, then we have to make proper use of all the parts of our code. For example, in the customer class, we have two properties that are same. For example, telephone number and area code. We can make another class for this purpose. Here we can see that we can make a class called customer ID, which will take the responsibility of generating a customer ID, and then at the customer we will use the customer ID class and the variable and the method called generate customer ID. We can have large class, as we seen before, we can break down the long method into small pieces. Similarly, we can break down the large class into small pieces. We can have long parameter list. In the picture we are getting that the very long parameters are going to the same method. This is not good for the code. A method for more than 4 parameters is considered as long parameter, so we will try to keep as low as possible parameters. If we make sub methods, then it will be easier to maintain the code. For example, the customer class can have 4 variables or 4 properties to add the toString method to print. But if we break down into a new class called telephone, which will take 2 properties and work with them, then our parameter at the customer toString will be reduced. Our next topic is object-oriented abusers. We will discuss about alternative class with different interfaces, refuse, bequest, temporary fit, and switch statements. In our code, there may be some situation that one class is thinking about a small car, one class is thinking about a private car, and one class is thinking about a truck. We can add all the features and make a good class. For example, in the customer, we have a method which will for 5% increment, 10% increment, and 12% increment. We can combine them and create a new method which will get increment and pass the percentage as parameter and calculation and do the calculation of increment, which will be more good as a code. Refused bequest. Let's see in the picture that a dog has 4 legs and a chair also has 4 legs. If we make an animal class which is extended by dog and chair, which will be okay for legs only, but not for all the properties of chair and dog. So if we make 2 different classes, animal and chair, and we use the property of leg, then it will be good for the code. For example, animal, if we use if dog extends the animal class, the get legs which returns 4 legs is okay, good for the dog, but it's okay for the chair, but only the 4 legs is okay and other things is not okay for the chair. So we can give a solution that we can create a class called leg, and it will implement it different according to the animal logic and according to the chair logic by animal and chair class. We can have temporary fit. For example, a class has some properties that are working and some properties that are not working. We have to use all of the properties or all of the methods to get a good output or maintainable code. Here is the solution that a class, for example, the property ABC is working and also the XYZ is also working. For example, the class order has a method called getPrice which contains a long calculation. We can break down the calculation into another class and use the method of the new class. Switch statement. In our code, there may be some situation that we are using many portions in the switch implementation, but we can have a good code if we break down the switches into different portions and use individually them. For example, in the switch method, we have a case Bikash, Nagad and Upay, and we will use the Bikash logic, Nagad logic and Upay logic, but we can make our code more maintainable if we create a class which is called payment and which has an abstract method called getAmount. Bikash extends it, Nagad extends and implements in their own class, and whenever the switch appears, the case Bikash appears, then the Bikash object will be called. Change preventers. We'll discuss about divergent change, parallel inheritance hierarchies, and shotgun strategy. So let us assume a class has these functionalities and now a change appears in the class, then it will be more complex to make the change. If we break down the class into both parts, then it will be easier to make the change. We can have parallel inheritance hierarchies. That means a class is extended by 2 classes and the child class may be extended by another class. So this will make the code more complex. We can have a new class which will be as a property in the child class. Shotgun surgery. In the shotgun surgery, in the picture we can see that the shotgun is asking for a change in the code. The project is totally connected and each class is connected with various classes. So if we add the common properties into 1 or 2 class, then we can make the change easily. For example, if we combine the 4 class and make 1 class, then it will be more easier to make the change. Dispensable. In the dispensable, we will discuss about comments, data class, lazy class, duplicate code, dead code, and speculative generality. Comments. Suppose we have a code of 10 lines, but we are implementing comments of 20 lines. It is not necessary. We have to reduce the comments and we have to remove the comments from our code. For example, we have a method which is get PRC. The method is not readable, human readable, so we have implemented a comment that the method returns price of the order. At the return annotation we have the price, but if we set the name as get price and the variable as price, then we can easily understand this method is returning the price of the order. Data class. Suppose we have a class and this class use different types of data, so we can make the code more maintainable if we use the data classes. For example, we have a class university which has a list of courses named as course list, and we have a class called course which contains the properties of a course. This is more maintainable as a data, and we can add more functionalities. That is, we can do any operation in the university and we can add course, and in the course list we can add a method called adding course. That means this course list will be added only using the add course method. Lazy class. In our project or in our code we may have some lazy classes. We have to reduce the lazy class because there are no need. For example, in the person class we have a name and get name and returns the name, but a class called Prosanto extends the person and there is nothing new here, so we have to remove this lazy class from the project. We can have duplicate code. If we have duplicate code, for in the example we have same pictures in the both, and we can add a reference or we can add a link to the existing code and reduce the duplicate code. For example, there is a class called student and teacher. In the student there is a properties name and method which returns the name. In the teacher also there is a property called name and which returns the name, but there is some code duplicacy here, so we can reduce by creating a new class called person which has name and which will return the name, and student and teacher both will extend the person class and use their other logic. Student will use student logic and teacher will use teacher's logic. In our code we can have dead code, so we have to use good compiler or good IT to find out the dead code and remove them. Speculative generality. Suppose we have 3 classes in use and we have made some other classes and some other features that we'll use for the future. We don't need now, so in this case we have to reduce them and make focus on the present condition. So we have to remove these extra features which we have preserved for future use. Couplers. In couplers we will discuss about feature envy, incomplete library class, middleman, inappropriate intimacy, and message chain. Feature envy. Sometimes it can happen that one class is getting more focused on the object or behavior of another class. In this case we have to make proper use of this class, or we have to implement the method in their own classes, or we can create a connection between all the classes. Inappropriate intimacy. In this picture we can see that a method, the different parts of method is connected with different classes. So for this reason we can break down this method into according to the responsibilities and distribute among the classes. Message chain. We can have a situation that a class is shouted as A and the message will pass through the all other classes. But if there is some problem or barrier in between the classes, then the other classes will not get the message properly. So we have to make a solution that the message is directly converted or directly passed to the target class properly. Middleman. In our code, we can see that the three classes have three same features as middleman. So we have to remove this middleman and make our code more maintainable. We can have incomplete library class. For example, in our code we can find a situation that our libraries are not useful anymore. We have to combine one or two libraries, so we can combine the libraries and use as we want. Thank you everyone for watching my presentation.